Hi everyone, I am Dr. K. Vijay Sundarvel, Assistant Professor in the Department of Civil Engineering at K.S.Rangasamy College of Technology, Tiruchendur. Today we will be exploring the design of a flat slab, a popular and efficient structural systems widely used in modern multi-story building. We will discuss their types, components, advantages, design assumptions, and practical applications. In this unit, we will cover basics and advantages of the flat slab, types of flat slab, components and structural sections, design assumptions as per IS-4 physics and other codes, application and limitations, design procedure for interior and exterior panels, reinforcement detailing, and punching shear check. Um, let's start by understanding what the flat slab actually is. A flat slab is a reinforced concrete slab of reinforced or nearly uniform thickness that is supported directly as column without the use of intermediate beams. It is also known as the beamless slab or column supported slab. When there is no drop panel and we column capital, it is called as the flat plate. Uh, Key structural features includes um, two-way slab action, direct load transfer from slab to column, high negative moments near columns, critical punching shear at the column perimeter. This is the comparison between the conventional beam slab systems and the flat slab systems. Whereas in the verticals of conventional beam slab systems, beam plus slab. Whereas in the flat slab, only slab plus column. In deeper floor height, it will be the conventional beam systems, reduced floor to floor height. Beam congestion for services is very economical. Cleaning ceiling, easy service layout. For more formworks are needed for the beams, simpler and faster formworks can be adapted for the flat slab systems. Um, some of the advantages of the flat slabs. Flat slab offers several practical and architectural advantages. Reduces floor to floor height, saving on building height and materials, faster construction cycle due to simpler formworks, flexible interior paneling, partitions can be placed everywhere, clean and attractive ceiling appearance, no beam producting, easier installation of service such as electrical and plumbing, better light diffusions and ventilations, improved the resistance due to uniform thickness, economically for a medium span ranges from 6 to 8 meters. If it is the advantages, there will be some disadvantages also. However, flat slab also have limitations and challenges. Higher self-weight due to the thicker slabs, critical punching shear fails, risk near columns, larger slab thickness requires compared to beam slab systems, higher reinforcement demand near columns, limited space capability, not suitable for a longer span, poor performance under lateral loads, example earthquakes, without additional systems, deflection controls can be challenging, not suitable for heavy concentrated loads, higher precision needed for the formworks, repair and strengthening can be difficult. These are all the typical application for the flat slab. Multi-storied residential apartments and condominiums can be adopted. Commercial office buildings, hotel and service apartments, hospital and healthcare facilities, educational institution like classrooms, lecture halls, shopping malls and retailing showrooms, parking structure, basement and multi-level car parks, industrial floors with moderate loading. Flat slabs are most suitable for column grid spacing is between 6 meters to 9 meters. Column layout is regular or near regular. Floor slabs are repetitive, typically in tower. Reduced floor height provided significantly advantages. Fast construction cycle is required. Flexible interior layout is needed. Architectural performance for cleaning, beam, free ceiling exist. Uh, so see here some of the real world examples when to use the flat slab. Um, Real world examples includes high-rise residential towers, for example G plus 50 to G plus 40 in urban India, IT office campuses and uh, SEC buildings, star hotels and uh, multi-specialty hospitals for cleaning, sealing and for hygienic services, underground and multi-level parking structure, exhibiting hall and conventional centers with a longer span and shear reinforcement. When flat slab become preferable over the beam slab. Um, when floor to floor height needs must be minimized, architectural or structural height restrictions exist. When formworks reuse or speed or priorities, when services layout will be maximum flexibility. And also avoid flat slabs to irregular column grids to various large spans like less than 10 mm to 12 meters. Heavily industrial loading or mechanical foundations, high seismic zones without additional moment frames, structural with heavy uh, point loads. These are all the types of flat slab and flat systems. The simplest type of flat plates, a flat slab with a uniform thickness and no drop panel and no column capitals. Main characteristics: simple geometry, cleanest ceiling, slab thickness constant throughout, load transfer purely by two-way slab action. Punching shear is most official design consideration. Typical thickness of 180 to 280 mm for span of 5.5 to 8.5 meter as per IS 4 physics. Minimum in L by D ratio, which is L by 30 to L by 33, which is in longer span. Some of the flat plate systems have the advantages: fastest and cheapest formworks, maximum ceiling height for the given floor to floor distance, easiest installations. Some main characteristics are simple geometry, cleanest ceiling possible, slab thickness constant throughout the panel, load transfer purely for slab actions. Punching shear is the most critical design consideration. Typical thickness governed by the deflection and punching shears. Some disadvantages of challenges are: lowest punching shear resistance almost always needs for the shear reinforcement, thicker slab request compared to drop panel system, deflection control is more uh, difficult, higher negative reinforcement, congestion near the columns. Uh, Flat slab systems uh, are ideal for span for 6.5 to 8.5 meter regular column grids, modernized loading, residential office or hotel floors which is adapted, building where clean ceiling and reduced height and priorities, fast track construction projects. Shear reinforcement is almost always required for span less than 6.5 to 7 mm. Common types includes prefabricated shear studs, shear rallies and ladders, closed links and stirrups. The critical shears for the shear check is to be D by 2 from the column face. A flat slab which drop panels includes the thickness portion surrounds the each column is increasing slab deeply locally. Drop panel dimensions as per the IS 461 practices width in each direction is 1 by 3rd to 1 by 4th of the panel span. Depth of the drop is 1/3 to 1 half of the main slab thickness. Main purpose and benefits are significantly improving the punching shear resistance, increasing the negative moment capacity near columns reduces required thickness of the main slab, lowering deflection in the panels, allow longer economic span up to 9 to 10 meters.